Testing 1, 2. Am I on? Cool. Hey, everybody. Let's go over some of your homework questions right from the start. In 4-1, I'm anticipating some of you might have had trouble with number 15. The function is f of x is equal to 3x squared plus 1 over x squared plus x plus 9. You're supposed to find the domain and identify any vertical and horizontal asymptotes. If you look at the denominator, this particular quadratic, you should recognize right away that its discriminant is negative. That means that quadratic has no real zeros, so it's never going to equal 0 in the real world. So we're not worried about it. That means there's nothing bad that we could plug in for x to make the denominator 0. So the domain is going to be all real numbers. And if that denominator never equals 0, that means there can never be a vertical asymptote. There is, however, a horizontal asymptote. And if you go back up here and look at the original function, 3x squared plus 1 over x squared plus x plus 9. The degrees of the polynomials are the same, 2 and 2, so that means you're going to take the ratio of the lead coefficients, and it's going to be y equals 3. If you imagine plugging in a huge number for x, like a billion, the top will be about 3 billion squared, 3 times a billion squared. The bottom will be a billion squared. The billion squared will cancel. You'll be left with 3. So as x gets huge, y approaches 3. And that's all you need for 15. Let's go on to section 4.2, where you had to actually draw some graphs, and it got kind of tricky to know how to do it without a calculator. So one of the ones we'll look at is number 25. 25, the function is h of x equals x squared over x squared minus 9. Hopefully the first thing you noticed to do was to factor the denominator. And let's pull out a little grid here so we can graph this puppy. Okay. Let's start with some easy things like the y-intercept. For the y-intercept, I think it's easier to plug into the unfactored version. It doesn't matter for this one, but in general, if you plug into the unfactored version, put 0 in for x. Annoying. You'll get 0 over negative 9. Take a look at why you get 0 over negative 9. That means it goes through the origin. 0, 0 is going to be a point on the graph. That's also the only x-intercept, because if you look at the numerator of the factored version, there's only an x squared in it. And the only time a fraction will equal 0 is if the top is 0 and the bottom is not. And x equals 0 is the only time that equals 0. So the origin is the only intercept. How about vertical asymptotes? You can see the factors of x plus 3 and x minus 3. So x equals 3 and x equals negative 3 will both be vertical asymptotes on your graph. So you should have had those with no trouble. Let's draw those in. And your horizontal asymptote, if you realize that the degrees are the same, x squared, that in the long run, y is going to approach 1. So we'll put that in there. Now, how do you fit the rest of the graph in? You could plug in some points. But if you plug in like 4, you get 16 over 7. That's a little more than 2. So you can put a point there. If you plug in negative 4, you get 16 over 7 again, so you can put that in. You could try plugging in 1 or 2 or something. But let's think about this. Look at your factored form over here. Think of it just like those polynomial graphs from last unit. There's 4 factors. One of them has multiplicity 2, and the other 2 have multiplicity 1. So 3 factors, but a total degree of 4. If we, like, we're ignoring the fraction. Just look, we have an x squared, an x plus 3, and an x minus 3. So that's kind of like a 4th degree polynomial where both ends would end going up. It's not a polynomial, so they're not necessarily going to point up forever. But because it's 4th degree and the lead coefficient is positive, both ends are going to be positive. And I know that they approach this intercept. So from the end, I could say, whoops. Let's get my pen back. From the end, it's going to approach the intercept. Also, the only time these graphs change from positive to negative is when one of those factors up here changes from positive to negative. You know what? Let's bust out the number line. I think that'll help some of you. Interesting things happen to this graph at 0, 3, and negative 3. At 0, you know the value of the function is 0. And at 3 and negative 3, you know the function is undefined. You should also know that both ends of the graph are positive. And since the x plus 3 and the x minus 3 have multiplicity 1, the graph will change from positive to negative there. Ooh, we have 2 negatives next to each other, but if you think about that, what's true about the x in the function? It's x squared. There's going to be a bounce there, so it's going to stay negative. Let's go to the graph, see what that looks like. Since that's x squared, it's going to look like this. And now if you just make everything approach the asymptotes, you get the graph. It's a little weird, and you get used to it with more practice. And if you want to plot more points to help you, you can. But I think that number line can help you as well. All right, end this video.